totally a good idea. Okay, we'll get going. And welcome to the desk of Ladyada.
This is a terrible idea.
Yeah, alright, well, we're trying.
Okay. All right, enough. That was some good cat times. All right, welcome to the desk of Ladyada, where we absolutely positively do not torture our cat.
Yeah.
There's no proof. He can't get on the witness stand. All right, do you want to go to the main view, or what do you want?
This is the main view.
Oh, right. Okay.
What do you want to do here?
Well, I can just talk about what I'm like poking at today, which is I want to take a little break and play with updating the speaker for Circuit Playground, because I'm working on upgrading the microphone. I'm pretty sure that's going to work. That's fine. But I want to upgrade the microphone the speaker while I'm at it. And basically, I guess we can go to the computer and I'll open up the Circuit Playground board. Wait, wrong version. Okay, so over here is a little mini speaker. And I have a really basic driving circuit going on here. It's basically just a transistor, which is totally cool. Basically a little transistor, and basically it's either on or off, and it's kind of using the speaker, even though it's a speaker coil, like it really is a coil. I'm treating it a little bit just like a buzzer. You can either have it on or off, basically just a square wave, and that works fine for like basic tones, like beeps and stuff. But I thought that maybe I could upgrade the speaker. One, I could use a slightly larger one, because on the SAMD board I have A0, that's the pin I'm connecting this to, and this pin is actually a V out, it's a DAC. You get a 10-bit DAC on here. And so whereas the previous Circuit Playground, which was a 32U4, it didn't have any way to really do like serious audio out, because it didn't have an analog output. It had, you could PWM it, but it was like, I kind of decided, well, I'm going to start with a transistor and see how that goes. But with this one, I have a shot of actually making this act more like a true speaker, because again, I have that analog input. And so I wanted to update this, and there's actually another thing, by the way. It hasn't really happened, but it's possible. If you connect this up to a timer and you're careful, it's never going to be an issue, because you'll have a square wave that will go high and low, which will connect this to and from ground. And for the most part, you toggle it and you get a square wave and everything's good. The problem is it is possible for somebody to pull this pin high and keep it high, and that would actually, this is like 8 ohms of impedance. This could burn out the transistor, because you'd be basically driving it with a DC load. It won't damage the speaker, because the speaker coil, it doesn't, well, I guess you could damage it. I haven't seen it damaged, but it's like, the coil is kind of interesting in that it's I think like the magnet, it's like disconnected, the speaker and the magnet are disconnected. So I'm not too worried about the speaker getting damaged, but the transistor definitely can get damaged. So I thought I would update this and maybe move to a Class D type speaker driver. And we have one in the shop. It's called the PAM 8302. And basically the way Class D amplifiers work is they alternate which pin is high and which pin is low. And they PWM it very fast, but almost all Class Ds, they have a bridge tied load where they alternate. And so and then they use the inductance of the speaker to filter out the high frequencies. So, they're not cheap. They're a little more expensive usually, because there's some logic inside of them. But the nice thing is that you don't need a lot of external circuitry, and they can be very small. Like compare this to an LM386, which has like, you know, big capacitors. You don't need a lot of big capacitors, and often there's gain control. So the only thing, I mean, I haven't gotten it working yet, but what I've been hacking on is not using the PAM 8302, but actually the PAM 8301. And the PAM 8301 comes in a TSOT 26. The only thing that it doesn't have is a, that the original one does is the PAM 8302 is the PAM 8302 has a negative input reference, which can help reduce noise. And I might need it, but you know, you might also not be able to notice a little bit of noise. So I'm just testing it on a breadboard right now before I go crazy and actually design a circuit with it. So do you want to go back to the overhead? So we've got two versions here. I've got this version, which is the PAM 8302, like it's the, let's see if I can bring this down a little bit. This version is the PAM 8302, and I've got the speaker just connected up like this. Like I just kind of like wired up a little speaker there, and I have it connected to the output. And then over here, I have another little speaker, because I was comparing the two, and then I just breadboarded up. I breadboarded the SOT 23.6. I just breadboarded this little chip on here, and then I just added a couple of components to, because it does need a capacity, you know, I basically don't have all the support components that I have here. So I just looked at the data sheet and just kind of wired it up. Yeah, that's cool. So yeah, this is I'm basically trying both and comparing them. Even though this one has more circuitry, I might desolder some of this just so I can have more realistic comparison, because I'm not going to have like a audio potentiometer, like audio level potentiometer. And then this is the PAM 8302, sorry, the 8301, which is a little bit less expensive, but it's also a lot smaller. Although this one does come in a DFN, it's hard to get in a DFN. So this might be a lot nicer. There's one interesting thing about the PAM 8301. Oh, can you go to the computer? So there's one interesting thing, because one thing you have to remember is the output from the DAC is going to be as much as 3 volts peak to peak. So what's interesting is I don't actually want a voltage gain at all. I just want a current gain. Which also makes me think like I could also just do like a single transistor as like, you know, like a emitter follower would basically act as just a current gain rather than like a voltage gain. I like the output of the DAC is going to be 3 volt peak to peak, and that's basically like you can't put 3 volt peak to peak into these little speakers anyway, so you're not going to be able to push that much current. So I can reduce that current in I can reduce that voltage by basically in the DAC just dividing it in code. But another nice thing is if I do want to use the Class D amp, it has inside of it an op amp basically. Here, you can see here, RI and RF. There's a RF over RI gain. Sorry, yeah. So right here, so if I want to reduce this gain, I just put a resistor in series with the input to make this gain lower. And so if you go to the overhead, this is, this here is that resistor. So I have a resistor in series because the gain of this by default is like 24 dB. It's way too high. So this lowers it a little bit. So I can play some audio out of it, although I don't know if we'll be able to hear it that well. Should I try? I can try holding it up.
You can try.
I can try.
It'll be okay.
Okay, so let's see. I had to like put non-commercial music on so I can play this. Hold on. So yeah, I have this kind of like jig with like a little iPod just to test the audio. And that's the audio. You can hear it a little bit. Let me see where the port is. So it sounds okay. I mean, it's a very small speaker. I'm not going to actually expect to get audio levels out of it. The thing I kind of want the most to get out of the speaker is the thing that I want to be able to do the most with Circuit Playground is if I can get it to speak words, like using the talkie library. That would be really neat. I want to be able to have it say like, oh, you know, the measurement is, and then like maybe like say like 3.58 volts or something. So I think that'd be neat to have like talking electronics, and I only needed to say basic words. So, you know, I'm not expecting, like, it's not going to be audiophile. Like, this speaker is super small, and, you know, when I have to divide down, I'll have to divide down this voltage or reduce the output bits of the DAC, so I'm not going to get, like, a ton of precision. But basically, yeah, if I can get, like, basic words or maybe slightly better than tones, because right now I'm just getting, like, very square, wavy audio. This might be a lot nicer. And also a little louder, which I kind of like. The Class D is a little louder than just the transistor drive. So that's kind of what I'm hacking on. Not working yet, but it's getting there.
You can hear the music. I know which songs they are. That's getting really good. And
Yeah.
for words, the human ear is pretty forgiving. So it's saying like press or plug in or something.
Yeah.
That'll be recognizable.
Right now, I've just got audio, whatever's like on my iPod, basically, is what I'm playing. What I'll do is I'll actually get like word. I'll use the AT&T Speech Synth site, which actually I don't know people have seen, so I should show people how to use it. So if you go to AT&T Speech Synth, this is a cool site. It's called oh, interesting. Yeah, so it's the text-to-speech demo. Whoa. Wait, is this down? Did they... Oh no, something changed. Oh no, here it is. So you can get voice samples. So let me pause this.
Have it say Circuit Playground.
Okay, so hello, Circuit Playground. And this is just for like evaluation and stuff, but it's really great if you want to test like the quality of your like text to speech. You can generate text to speech with like Linux, and you won't have to deal with like licensing. But it's just really fast and easy. So then you click submit.
Hello, Circuit Playground.
So then you get audio,
Hello, Circuit Playground.
and then you can download this too, or used to be able to. Maybe they don't anymore. I think they sold it. We used to be able to.
It looks like it's flash now.
Yeah, that sucks. They used to let you download a WAV file. That'd be a bummer if they took it away, because that was really useful. Because like otherwise you have to kind of like get a different program. There's open source programs that do text to speech. Looks like you have to pay $250 or $150.
That's not bad. I mean, in fact, yeah.
Well, you know, that's how it goes. It used to be you could just it would generate a WAV file for you, and you could download it and then like load it. So on the Wave Shield, that's how I generated some examples.
Yeah.
So I'll probably end up finding something similar to this, putting it on my iPod, and then just like having it say like pi or a couple of like text to speech type voices, and then the Circuit Playground has enough storage that I can generate those waves and then store them in the Circuit Playground itself on the SPI flash. Like 2 megabytes of 8 kilohertz audio is like quite a few seconds, so I can have like a wide range of spoken words.
Okay.
But yeah, right now, like I tried it with the 32U4, like to play the talkie library, and the square waves made it way too distorted. So, but I'll probably do that next. Like again, I'm not expecting to get like audio file, but I'll probably generate some text to speech, get it on here, and then just play it on the iPod until I feel like I have the settings and the gain, everything right, and then I can use the Circuit Playground analog output to play files, basically. It's going to take a couple steps. I have to, like, write some code to do that. So that's why testing with an iPod is a lot easier.
Okay.
Yeah. This is an update.
All right.
No real progress yet. It's still working.
All right. So that's it for tonight.
Yeah.
Okay. Well, thanks for turning in to the Desk of Ladyada. You can support our show by purchasing something on Adafruit.com. Tomorrow night is exciting because it's Wednesday night, 7:30 p.m. Eastern Time, show and tell, people around the world showing and sharing their projects. And then at 8 p.m., we have Ask an Engineer. And then super duper special treat, 9 p.m. on Thursday, a special edition of Ask an Engineer where you interview Bunny probably for about a couple hours.
It's amazing.
Yeah, so this is a rebroadcast of an interview that we've not played live yet.
Yeah.
In this time-shifted universe, everything is live or recorded depending on your position and speed. So that's what's going on. And thanks for viewing. Ladyada, thanks for sharing.
Yay.
Sharing is the rent that you pay for your room on planet Earth.
Okay. Thanks.
Bye.
All right. Cheers, everybody. Thanks for watching.